Hello ladies and gentlemen, welcome back to another video. Today we're going to be talking about adding and subtracting complex numbers. Okay, so what happens if I have two complex numbers? I need to add them or subtract them from each other. And basically what I want you to think of is when you do it this way, it's almost kind of like combining like terms. Okay, you're going to kind of treat the I or the imaginary term separate from the real term that doesn't have the I with it. Okay, and basically you just add and subtract those parts separately and you'll be good to go. So you see there's all this definition. They write down here like, oh, the sum, you add your real terms together, you add your complex terms together. Really the main thing that you want to think about is it's almost like it's like combining like terms. Okay, my things that don't have an I add or subtract them together. My things that do have an I add or subtract those together. Bada bing, bada boom, I've added or subtracted my complex numbers, okay? One thing I do want to point out is some of these properties that we kind of talk about. You know, in the real number system, we talk about, okay, here's what your inverses are, here's what your identity is, blah, 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 blah. What's a little bit different with the complex numbers, you know, your identity is still 0, that one stays the same, so 0 plus 0i. But the additive inverse is actually going to be this negative a minus bi. Those are the things that will undo each other and get you back to that identity, that 0, okay? So let's go ahead, let's take a look at what this looks like, adding, subtracting complex numbers. So down here, I see 4 plus 7i plus 1 minus 6i. Those are my two numbers. And again, I'm just going to add these individually. So I'm going to be doing 1 plus 4, right? And then I'm going to be doing 7 minus 6 to get what the I terms is. Again, very similar, just combining like terms. If you think of I like a variable, even though we know it's the square root of negative 1, if you think of it like a variable, you'll figure out how to do this, okay? So 1 plus 4 is 5, 7 minus 6 is 1, so we'll get 5 plus I as our answer. Okay, down here we're subtracting. I kind of like to think of this almost like we're distributing that negative like we would, again, with a combining like terms problem. So it's really kind of like 1 plus 2i minus 4 plus 2i. And then we'll go ahead and we'll combine the like things together. So 1 and negative 4, that's going to be negative 3. 2i and 2i, that will be 4i. So negative 3 plus 4i, there's my answer. For the bottom, for the next one here, again, we're going to have negative 2 plus 2, that's going to be 0. And then we're going to have 3 plus 5, and that's going to be 8i. I really don't need to include the 0 when I'm writing this out. I can just write this answer as 8i. This is a purely imaginary number, right? This is one that does not have a real component. It's just imaginary, okay? And then last but not least, we have negative 2 plus the square root of negative 8, 5 minus the square root of negative 50. Okay, if I make this square root sign so we can see a little bit better. All right, so what am I going to do? Well, I need to simplify these square roots. So we're going to leave it as negative 2. But then the square root of negative 8, remember, I can rewrite that as the square root of negative 1 times 4 times 2. Over here, I'm going to keep my plus 5. And then underneath, I'm going to have minus the square root of negative 1 times 25. Times 2. And then we'll go ahead and we'll simplify from there. Over here, I'm going to get negative 2, and then we're going to get plus 2i root 2. Over here, I'm going to go ahead and simplify this as well. We're going to get 5, and then minus 5i root 2. And now we're going to go ahead and combine the like terms. So negative 2 and 5, that's going to equal 3. Here's where it gets a little tricky. I have 2i root 2 and negative 5i root 2. What that's going to add up to is it's actually going to be minus 3i root 2. Okay? If you want to know where I'm getting that from, basically I'm kind of thinking almost like when we kind of just pull out whatever that coefficient is. So it's kind of what we have is like 2 root 2 minus 5 root 2 I. And then we simplify this, and 2 root 2 minus 5 root 2 is going to be negative 3 root 2. If for some reason these square roots did not match and I couldn't simplify this anymore, you would just leave it as that kind of really ugly answer I that's there, okay? So if that was the case, if this was a 3 for some reason or something, you would do that, okay? But otherwise, that's all you have to do. So this last one, the only thing that was different is that it kind of added in what we did yesterday, where we simplified the negative square roots in addition to our new step of adding them together, which we did in these other ones. Okay, so that's our answer for that one. All right, so that's how we're going to add and subtract complex numbers. Thank you all for watching.